When the calculation is completed, 1D viewer will be run automatically. Through the Graph tab, you can check the graph result. If you add the color filter into the stack list, you can see red, green, and blue cells independently. However, we did not add it, so just no CF appears. And when you define a single domain or a multi-domain, you can select a particular domain and see the calculation results. But we don't use it too, so only no domain appears. The next one is display type. There are transmissive, reflective, and transflective types. In this case, please select transmissive type. Select the variable on the x or y axis. At first, let's check the simple VT curve. Select voltage for the x-axis and transmittance for the y-axis. And then click plot. As you know, TN is the normally white mode, so VT curve shows that this TN example is the normally white mode. And go back to the result panel. In the variable window, you can select the condition of the variable to be output. For example, if you want to output the VT curve according to the theta angles, select theta to variable. And then click plot. As a result, the x-axis is voltage and y-axis is transmittance. Additionally, the output VT curve is the results of theta change. In the right window, there are some functions to analyze the graph result. I will not mention all of them, so if you want to know in detail, please refer to the manual. So, there is a graph option. You can set the various line options and turn on and off the graph lines. Also, through the axis option, you can define the left, bottom, right, and top scales of the graph. Trace tool can check the data, mean, and max values at the particular location. An integrate function displays the integral, average, mean, and max values of the range. And using fitting option, you can check the fitted graph and values by entering the order. Lastly, if you click this raw data, the data is displayed in table form, and by clicking the right button, you can export the data as a CSV file. So we have checked about the Graph tab. And let's go back to the result panel. The next one is polar chart. For the polar chart, from subcell to display, they are the same as the Graph tab, so I will skip it. And for the data, let's select transmittance. And then if you want to see the polar chart according to the applied voltages, select variable for the voltage. Also for the wavelength, select average. After that, click plot. The output result is a polar chart representing the transmittance. We set the variable for the voltage, so please check the voltage condition. When we define the azimuthal angles of the LC, the dark direction is 6 o'clock. Let's check about it. If you look at the legend displayed on the right, you can see that when the transmittance is low, it is blue. When the transmittance is high, it is red. As the applied voltage increases, it can be seen that the red part gradually disappears and changes to blue. This shows the characteristics of TN that changes from normally white mode to dark as the voltage increases. Especially, you can check the dark direction at the 6 o'clock at the dark state. And on the right, you can identify the mean and max values and average. Through the view control, set the line options. For example, please check highlight line and enter the value as 0.05. The dotted line represents the transmittance as 0.05. And then please click close section theta pi. You can extract the transmittance data according to the viewing angles. Click phi and move the slide bar or enter the particular angle. For example, like this. And then select all voltages. After that, click extract. The extracted data is shown by user-defined angle. And the next one is data extraction specific angle. Move the theta and then click add. As the same way, move phi and click add. Select the x-axis, for example, voltage. And for the data set, please select all variables and then click extract. This is the VT curve by user-defined angle. And additionally, through the data table, you can check the raw data. And let's move on to the next tab. Click 3D Graph tab. 1D viewer can output the 3D graph. If you want to plot the contrast according to the theta and phi angles, please set the conditions like this. As we want to check the contrast result, select the voltage condition for the white and black states. I will use it as default. And then click plot. On the right, there are various options for analyzing the data, so you can utilize them efficiently. And the next one is the Director tab. It can be used to analyze the movement of LC according to applied voltage or time. X-axis is voltage and Y-axis is cell gap. Then click plot. as we defined the number of divisions for the LC as 15, so y-axis shows from 0 to 14. Please click Highlight X and change the voltage. You can see the director distribution for each x-axis value. And by using these functions, you can analyze the director result effectively. So please check about them by yourself. So we have checked graph, polar chart, 3D graph, and director tabs. For other tabs, I will talk about them later on. And let's go back to the 1D program.